All right, I'm going to do another projectile motion problem for y'all. This time I want to solve for time. So in this problem, I have a person who's going to run off a high dive, not jump, run off a high dive at 3 meters per second, and the high dive is 2 meters high. Now I figure out how long this person is going to be in the air before they hit the water below. Okay? Let's write down what we know. Okay? I've been told velocity initial in the x direction is going to equal 3 meters per second. I know delta y is going to be equal to 2 meters. Both of those things have been given to us. Okay? Let's see if we can figure out the accelerations. I'm going to go off to the side and draw myself a little FBD of the guy as he's in the air, say when he's about here. Again, as we've seen in other projectile problems, I have only force gravity. So if I have only force gravity, I know that my acceleration must be gravity. Okay? That arrow is only pointing down. It's not pointing anywhere to the side. So the acceleration in the y direction must equal gravity, which is about -10 meters per second squared. There's no forces in the horizontal direction. It is totally balanced. That means that the acceleration in the x direction is going to be 0 meters per second squared. I'm not given delta x. I don't know what that is. And I need time. Great. Let's take a look at our formulas. I bet I can use our handy-dandy delta y equals velocity initial in the y direction times time plus 1/2 acceleration in the y times time squared to my advantage. Okay. Velocity initial in the y, I didn't list it over here, but because this velocity, the initial velocity is only in the horizontal direction, I know that velocity initial in the y direction must start off at 0. Okay, meters per second. So already I know that velocity initial is 0 times time, so we're going to end up with crossing that out. All right? I want to get time by itself. Let's do a bit of algebra. I'm left with delta y equals 1/2 acceleration of the y direction times time squared. I see this 1/2. I'm going to multiply by 2 to make it a 1, but I have to do that on both sides. I see an acceleration, so I need to divide that away. All right, let's see what we've got now. 2 times delta y over acceleration in the y direction equals time squared. I want just time, not time squared, so I'm going to square root both of these, and I am left with time is equal to the square root 2 times delta y over acceleration in the y direction. Let's plug our numbers in. Time is equal to square root 2 times 2 meters over 10 meters per second squared. I would put that negative in, but you cannot have a negative under the time, under a square root, not a time, under the square root, so I'm just going to put it as a positive number. Let's plug this into the calculator. So 2 times 2 divided by 10, square root 0.04, square root of 0.4, my bad, square root 4, going to equal 0.63 seconds. That's how much time they're in the air. I could figure out delta x because I have time now. So delta x, we can use that same formula, equals velocity initial in the x direction times time plus 1/2 acceleration times squared. That's going to be 0. We have my velocity initial from over here. We have time now. So if we plug it in, it's going to be 3 meters per second times that 0.63 seconds. That's going to give us 1.89 meters. Okay, I think I'm going to do another problem to show you another thing you can solve for projectile problems, but this looks really good. Okay.